So here we have another problem, and I'm just going to go and highlight sort of the essential bits and pieces for that. So we see we've got an acceleration statement, 4 minus 3t. We're told the particle is at rest when t is equal to 2 seconds. So that's some more information, and we want to find an expression. So find an expression for its velocity. And what other time is the velocity equal to 0? And then lastly, if the particle is at the origin when the timing starts, find the distance after 3 seconds. So I'm just highlighting some key things. So again, just a reminder that if I've got S, V, A, displacement, velocity, and acceleration, I'm starting with acceleration, initially working back towards velocity and then to the distance or displacement. So all of this involves anti-differentiation. So let's start then by anti-differentiating the expression for the acceleration, 4 minus 3t. So the velocity is 4t minus 3t squared at 1 to the power, divide by that power, plus c, the constant of integration. So if it's at rest, so to calculate c then, this information that v is at rest, in other words, if it's at rest, it's not moving, therefore the velocity is 0, and that occurs after 2 seconds. So we can use that information to calculate c. So we just substitute, velocity is 0, and time is equal to 2. So we just do a substitution, and we use that to calculate c. So that's equal to 8. And I just realized I put a mistake there, which we'll fix up. That's actually 2 squared. So in that case, here we've got, that's 4 divided by 2 is minus 6, and plus c, and that's still equal to 0. And from that, to get 0, c needs to be equal to negative 2, 8 minus 6 minus 2. We now have a statement for the velocity. So velocity is equal to 4t minus 3t squared over 2, and that's minus 2. So that's the velocity. So look, what else are we asked to do? So we've got that now. So that A is done. We've found an expression for its velocity. Then it says at what other time is the velocity equal to 0? So what we need to do is set the, now we know the velocity is equal to 0 when time is equal to 2. So I'm going to set this expression to 0, 4t minus 3t squared over 2 minus 2. And it would be convenient if we could multiply everything by 2 to get rid of that fraction. So we're allowed to do that. So 2 times 0, so as long as I multiply both sides of the equation by 2. So 0 times 2 is not 2, 0 times 2 is 0. That gives us 8t. This times 2 is minus 3t squared, minus 4. Now what I'm going to do is multiply by everything by negative 1. And then I'm going to rearrange. So 3t squared, I'm shifting that over here, minus 8t plus 4 is equal to 0. So by multiplying everything by negative 1, we get that. By the way, what we could have done, if all of this is a little complicated, I could have taken A is equal to negative 3 over 2, B is equal to 4, C is equal to negative 2, and put that into the quadratic formula, and I would have got the result. Now, we know that we've got a result of t is equal to 2. So I put t minus 2 in here, which gives me t minus 2. And then that must also be minus 2. So basically I'm factorizing that. And this part here, that's a clue because of what we've got over here. Again, if you don't get that, again, it's still possible just to go ahead and factorize those things. So solving that, t is equal to 2, and 3t minus, what's happening? 2, and 3t minus 2 is equal to 0. So rearranging, I get add 2 to both sides, divide by 3. And so there it is there. There's the t equal to 2, which we already know. And there's the other value, t is equal to 2/3. So let's look again what the next part in this is. So we've done B. If the particle is at the origin when the timing starts, find the distance travelled after 3 seconds. All right, so there's actually a little bit more information there. So choose a new colour. If the particle is at the origin when the timing starts. So that's an important term. We'll come back to that. But what I need now is I need to find the distance. So that's an expression for S. So I've got a velocity statement here, which we now anti-differentiate again to calculate S, or D for distance if you want. So if we anti-differentiate this for t, becomes 4t squared over 2. Add 1 to the power, divide by that power, minus 3 over t cubed, and then divide by that power, so that becomes times 3 down there, and minus 2t, and then plus c. So just a little bit of tidying up, and 4 over 2 is 2, so it's 2 squared. Those 3's cancel, so I've got minus t cubed over 2 minus 2t, and now plus c. I'm going to go back and have a look at what this statement says. It says if the particle is at the origin when the timing starts. So if it's at the origin, so anything at the origin means that the distance is actually equal to 0. So that means S is equal to 0. And t is equal to 0, because that's when the timing starts. Now, if those two are 0, then c is also going to be 0. You can see there if I substitute 0 in for s and 0 in for t, then c is going to be equal to 0. So I've got a statement now for s is equal to 2t squared minus t cubed over 2 minus 2t, and we don't need to write the plus 0. So the other part of the question is how far has it gone after 3 seconds? So we substitute 3 into that. Pen's given up. So really has given up. Nothing else is working either. We'll try this again. All right, I'm going to stop it there because, but we can see we can put 3 in here. So I'll just tell you what the result is. So 2 times 3 squared is 2 times 9 is 18. Put that on the calculator. And then we're going to go minus 3 cubed, which is 27 divided by 2. And then minus 2 times 3, which is 6, and we get a result of negative 1.5.